Section 8.2 is dividing monomials, so we're going to learn some more rules about exponents today. Add to our list. So the first one is the quotient of powers. We did products the last time in 8.1. Now we're doing quotients or division. To divide two powers that have the same base, again, having the same base is critical here, subtract the exponents. So when we multiplied, we added the powers. Now we're subtracting the powers. A to the m over a to the n is a to the m minus n. Looked at this way, 5 minus 3 is 2, and we know that 6 squared is 36. Let's just take a brief look at why this works. If I have x cubed over x squared, the rule says to subtract the powers. But we also know that x cubed, another way to write that, is x times x times x. Another way to write x squared is x times x, and if I cancel the common factors, I'm left with just x. So whatever power is on the bottom, we can cross out an equal number of powers on the top, hence we use the subtraction. Now let's try a couple of these. I'm going to give a couple examples. So a to the 5th, b to the 8th over ab cubed. Now we've got to keep the bases the same, so I'm going to work with the a's separate from the b's. Your book has you write them as two separate fractions. I'm not sure that's necessary, but 5 minus 1 is 4. 8 minus 3 is 5. Okay, try this one on your own. I've also put some coefficients in, so you're going to have to simplify the coefficients as well. So pause it and try this and come on back. Okay, 6/12 is 1/2. X cubed over x, 3 minus 1 is 2. And y to the 5th over y squared, would be y cubed. 5 minus 2 is 3. We don't need to write the 1, so a cleaner form of this would just look like this, x squared y cubed over 2. Okay, the next rule is called the power of a quotient. And you don't need to memorize the names of these rules, you just need to know how to use them. To find the power of a quotient, in other words, the power of something that is being divided, find the power of the numerator and then the power of the denominator. So 2 over x cubed is the same as 2 cubed divided by x cubed, and we can simplify that to 8x cubed. Here's our second example. Again, the entire numerator has to be squared. So in order to do that, we might want to write an in-between step here. 2x cubed squared over 3y squared, and then we're going to use our power rule, power of a power, to get 2 squared x to the 6th. Same thing down here, power of a power, 3 squared y squared, and now I can do some simplification. 2 squared over 3 squared is 4/9, x to the 6th over y squared. Let's try a few more of these. So the first one we're going to look at is 2p squared over 3 all to the 4th power. So again, think of it kind of as distribution. Remember, this can only be done with products and quotients, not with addition or subtraction. So 2 to the 4th, p to the 8th, the power to a power. We multiply the 2 and the 4, and the bottom is 3 to the 4th. Oops. So 2 to the 4th, p to the 8th over 3 to the 4th. 2 to the 4th is 16, p to the 8th. Oh, come on. And 3 to the 4th, we should know 3 to the 1st. All right, 3 squared is 9. 3 cubed is 27. 3 to the 4th, 27 times 3 is 51. So we can figure these out pretty easily. I'm in trouble with my pen all of a sudden. All right, try this one. And I'm going to go ahead and erase what's on the screen so that we can have a clear page. So here's another example. I want you to try this. 6x squared y over 5x all to the second power. So try that on your own and come back. Okay, probably you did 6 squared, x to the fourth, y squared, over 5 squared, x squared. So that's 36 x to the fourth y squared over 25 x squared. I now need to use my quotient rule again. So I have 36 x squared y squared over 25. Let's take a look at this one again, because I could have also simplified before I raised it to the power. I had this x squared over x. So I could have rewritten the inside first and then squared everything. And I would have gotten the same solution. So sometimes we have to use more than one of our rules, and sometimes we can do it in a different order. It really doesn't matter as long as you're following the rules. Okay, 0. Any non-zero number raised to the 0 power is 1. A to the 0 is 1. 2x cubed over 3y, all raised to the 0, is 1. So a lot of times people want to know, why the heck does this work? So if I have x to the fifth over x to the fifth, using my quotient rule, that would be 5 minus 5, which is 0. But I know from experience that if I have any fraction where the numerator is exactly equal to the denominator, that always equals 1. So if x to the fifth over x to the fifth equals x to the 0, and it also equals 1, we know that x to the 0 must equal 1. So anything to the 0 power will equal 1. So let's try a couple of these. X cubed y to the 0 over x. Well, y to the 0 is 1. And 1 times x cubed is still x cubed. Then I can use my quotient rule. 3 minus 1 is 2. Here's another one. 3x squared y to the fifth over 12x y to the fourth all to the 0 equals 1. Anything to the 0 is 1. Okay, the last rule we're going to look at today is negative exponents. For any non-zero number a and any integer n, a to the negative n is the reciprocal of a to the positive n, or in other words, 1 over a to the n. So in simplest, a to the negative n equals 1 over a to the n. Since this can also work in reverse, 1 over a to the negative n equals a to the positive n. So this rule can be done two different ways. The main idea here is that if you have a negative power in the numerator, you need to bring it to the denominator and make it positive. If you have a negative power in the denominator, you bring it to the numerator and make it positive. So here's two quick examples. X to the negative 3 is 1 over x cubed. 1 over y to the negative 2 is y squared. And again, why does this work? Let's look back again at our quotient rule. What if I had x to the fifth over x to the seventh? If I use my quotient rule, I would say 5 minus 7 equals x to the negative 2. But if I use common sense here and say x to the fifth is 5 x's being multiplied together, and x to the seventh is 7 being multiplied together. Again, if I cancel common factors, I end up with 1 over x squared. So if x to the 5th over x to the 7th equals 1 over x squared by canceling, and if x to the 5th over x to the 7th equals x to the negative 2 by the quotient rule, then x to the negative 2 must equal 1 over x squared. All right, let's try a couple of these. B to the negative 3 over c squared over d to the negative 5. Anything with a negative power is in the wrong place. So c squared is where it belongs. B to the negative 3 comes down and becomes a positive 3. B to the negative 5 comes up and becomes a positive 5. Okay? Try this one on your own. Negative 3, a to the negative 4, b to the 7th over 21. Actually, I'm going to take this negative sign away. Over 21, a squared, b to the 7th, c to the negative 5th. See if you can simplify that on your own and come on back. Okay, there are several ways to approach this, so I'm going to do this more than one way. Should erase this first. Let me erase that, and I'm going to bring this up to the top. 3a to the negative 4, b to the 7th, over 21a squared, b to the 7th, c to the negative 5th. Okay, so none of these ways are better or worse than the other. It's just whatever you see. The goal here is to use one or two of your rules at a time and just to do something. So the first thing I'm going to do is I'm going to simplify this to 1/7. I don't need to write the 1. Then I'm going to use my quotient rule on a to the negative 4. So a to the negative 4 minus 2. I'm going to do the same thing with my b's. B to the 7 minus 7. And I want to leave this c to the negative 5 down there for now. So now I have a to the negative 6, b to the 0, over 7c to the negative 5. That becomes 1. These two are in the wrong position. So c to the 5th comes up, a to the 6th comes down. You notice I didn't move the 7 because it has an understood positive power of 1. The only thing that has the negative power here is the c to the negative 5. Let's look at this same problem another way. This time, the first thing I'm going to do is take anything with a negative power and move it. So I've got 3 b to the 7th. They're still all on top because they had positive powers. I'm going to bring the c to the 5th up. I have 21a squared b to the 7th on the bottom. None of those have to move. And I'm going to bring the a to the 4th down. Now using my multiplication rule, the top will stay the same because there are no like bases. The bottom, I can make that a squared times a to the 4th into a to the 6th. Okay, the b to the 7ths cancel. And then the 3 over 21 simplifies to 1 over 7. And I did end up with the exact same answer. And you may have done it a different way as well. And we'll talk about that in class. There's tons of ways to do this. All right, so what I would like is for everyone to try this example on their own. 18x cubed y to the 4th z to the 7th over negative 2x squared y z all raised to the 2nd power. You know what? I better make that a smaller number that you can work without a calculator. So do this problem on your own, and when we get back to class, oh, I'm sorry. Oh, my goodness, that should have been a negative 4. When we get back to class, we will work on this one together, but everybody should give it a shot.